What is wrong with this place? Okay, look, you want to see what I'm looking at? What if it's mine? Looks like he's doing something.
The last piece of section 3.2 is the intermediate value theorem. I'm going to write it, then I'm going to draw a picture and explain what's going on. So, let f be a continuous function. Yeah. Let A and B be elements of the domain of F with A strictly less than B. Then, for every Y such that Y is between f of A and f of B, there exists a C such that C is between A and B, and f of C equals Y. So, here's a picture for you. Let's say that this is F. Now let's further say that this is A, and I guess I'd rather extend this a little bit. Let's say that this is B. So that Y value right there is f of A. And that Y value right there is f of B. So what this theorem says is that if the function is continuous, which means it's one connected piece, then somewhere, if you pick a value that lies between f of A and f of B, so for instance, if I picked, say, this value right here and called it Y, I know that's kind of squished in there. What the theorem says is there has to be some point between A and B where that's the value of the function. It's like if f of A were 5 and f of B were 3, there would have to be some point between A and B where the value of the function was 4 to get from 5 to 3. Or, for instance, 3.2. Because if the function's continuous, to get from that point there to that point there, you've got to somehow cut through this region right here. It doesn't tell you where that point is, it just says that such a point has to exist. Now, believe it or not, you've actually used this, probably, in the past without knowing it. So, do you guys remember back in probably Algebra 1, you were probably on a graphing calculator and you were graphing something, and then you looked at the table, and you were looking for where it crossed the x-axis, you know, where it's equal to 0. And you could look at the table and see, okay, so the function's negative here, and then it changes to positive there, so it's got to be 0 between those. Does anybody have any idea what I'm talking about? Well, anyway, that's because of the mean value theorem. because we all know that if you've got a graph, and like if this point on the graph is here and that point on the graph is there, it's got to cross through the x-axis somewhere in between those. So, for instance, show that f of x, which is equal to x cubed minus 2x minus 5, has a 0 between 2 and 3. First, we can examine what f of 2 is. What is f of 2? It's negative 1. 2 cubed is 8. 2 times 2 is 4, so 8 minus 4 is 4, minus 5 is negative 1. All right. F of 3, let's see, 27 minus 6 would be 21, minus 5 is 16. So, because one of those is negative and one of those is positive, 0 lies between those two function values, right? And so, as a result, that means that somewhere between 2 and 3, f of x is equal to 0. So, since zero lies between negative 1 and 16, there exists a c such that c is between 2 and 3, and f of c equals 0 by the intermediate value theorem. That's what IVT is, intermediate value theorem. All right.
You have to write it.
Well, I don't remember how the homework has you work on it, and I don't think there's a test question about that, so however the homework does it would be the only way that you would have to worry about that. And I think we all know by now that there's not really a way to type in a sentence into the homework, so I wouldn't concern yourself too much over that. But thanks for caring. All right. So, let's move on to 3.3. Because the quicker we can gain an understanding of what's going on with all these, the better chance we have of getting that test in before spring break. Let me ask you this. Right before Christmas, did we do any extra material at all? Like, did we talk about dividing polynomials, either long division or synthetic division? Does anybody remember? Maybe? Okay. So, let's just do a quick recap then. If you're going to long divide with numbers, let's say I want to take 437 and divide by 17. So you take the 17, 17 doesn't go into 4, but 17 does go into 43 twice. So you write a 2 up there. 17 times 2 is 34. So then you put a 34 right here. You subtract. That's 9. You bring down the 7, right? And then 17 goes into 97 5 times. 17 times 5 is 85. 85. And you have a 12. Now, technically, you could keep going by putting a decimal point in a 0, and you could get a decimal. However, if 17 doesn't go into 12, then 12 is the remainder. And so what you do is you make this 25 and 12/17. So you make it a fraction. And you put the remainder over the divisor. The divisor is the thing you're dividing by. And the thing you're dividing into, incidentally, is called the dividend. Hopefully that seems kind of familiar. So let's switch to polynomials. So let's say I want to take x squared plus 10x plus 21 and divide it by x plus 3. Now I understand that some of you see right away how that's going to work, and that's great. But let's say that you didn't. Let's see how this would work with long division. So I got x plus 3, and this will be x squared plus 10x plus 21. And remember, the key is to look at this first piece right here and that first piece right there. You say to yourself, self, what would I have to multiply x by to get x squared? X. I'm glad you answered yourself out loud. So then what we do is we distribute that x. It's just like, remember when I did off to the side, like 17 times 2 and 17 times 5? That's the exact same step. Some of you don't need to write this out. You could just do it, but in case you need to write it out, there it is. So we distribute. So this would be x squared plus 3x. Now, if you remember, the next thing we did was subtract, right? But chances are, and I'm going to be honest, if I just subtract, I make a sign mistake about half the time. So if I make that many sign mistakes, chances are you're going to mess up at least once. So, to prevent that, instead of subtracting, we change the signs and we add. What's that? Distribute the x to here. So you're distributing x to this whole thing. Sound good? All right. So then this becomes, I need to silence my phone because I think I just got in on the group text and it's probably going to explode. This would be 7x, and then you bring down your 21, right? Sound good so far? And then I take a look at this first piece again, and I say, what do I have to multiply x by to get 7x? 7. So this would be plus 7. I distribute 7 to the x plus 3 that I'm dividing by, and I get 7x plus 21. Change the signs, add, and you get 0. Which means that the answer was just x plus 7. Which makes sense because x squared plus 10x plus 21 is x plus 3 times x plus 7 if you factor it.